Good morning, everyone. Last week we completed almost 90% of this lesson. We have done resultant force, resultant of two forces, collinear forces, and resultant of two non-collinear or parallel forces we discussed, right? And two forces, I give summary also. When two forces are acting in the same line, same direction, and two forces opposite direction in the same line or collinear, and then two parallel forces, same direction. How to find the resultant we discuss. So the last page, resultant of inclined forces. In other words, non-parallel forces, two inclined forces. So that's what we can complete this today. This page, after that, I have already shared, I think yesterday I shared this also with the WhatsApp group. 10th lesson chemistry, that is chemical bonding, chemical bonds. So that what, so this is also, I mean, today we can start this also. Anyway, you are supposed to complete until chapter 14 for this term. And midterm break you get, I think, next Friday, the government schools, 10 days holidays. That is for, I think, it's for all paper mark in last batch. And 10th lesson is a little longer than the content is more than the 9th lesson. And from 10th lesson, you are getting sometimes essay type questions also is important and it's little difficult also. And that is the third chemistry lesson in your syllabus, grade 10, unit 3 chemistry, unit 7 calculation, chemistry, chemical calculation, and then the 10th lesson chemical bonding. Right. Before that, we'll complete, let's complete this resultant force, the last page. Resultant of two inclined forces. Now, one example here. So here you can see the resultant act two inclined forces. So here the resultant act in a direction which lies between two forces. What does this mean? Now imagine a situation if someone is pulling from your left, right hand. When you stand like, you keep your hands like this at an angle 90 degrees. And same when someone is pulling from your left hand and the other one pulling from your right hand, will you move towards either side? I mean, like this kind of situation. Someone is pulling from your this hand and the other person is pulling from your this hand. Which direction will you move? Will you move towards this person or this person, or like what will happen? I'll put this is P, this is Q. So they are pulling from your hand like this. So in which direction you are moving? Towards P or towards Q or in between? In which direction you will move? You are moving in a direction between P and Q. That's very important. That is the resultant, student. That is R. So you will move in a direction not towards P, not towards Q, in the direction in between P and Q. That is called the resultant. Is that clear? Not towards Q, not towards P, it's in between. So that is so similarly, they will never ask you to calculate. So this resultant is not it's beyond your syllabus. Magnitude of the resultant not expected under O level, right? To calculate the magnitude of resultant is not, if you only write that, calculation of the magnitude of the resultant force is not expected, but direction of the resultant force you should know, right? Calculating the magnitude of resultant not expected under your level. A level yes, but not of O level. Calculating the magnitude of, that is the value. Magnitude of the resultant force not expected. But direction, yes. You should know how to mark the direction. You better note down, otherwise you will try to calculate that also. Right now, example, if here that is the motion, that is the direction of motion. Can you mark here R? R is the resultant, and that is the direction of motion of the ring, not towards, not towards you. R is the resultant force. Okay. Okay. Hurry up, students. I'll give an example. Sometimes they can ask 20 Newton. Assume P equal 20 Newton. Imagine this side, this is the resultant should be less than 20, less than 40, more than 20. Less than 40, more than 20. In between. It will be in between 20 and 40. What? Resultant force. You can't tell 40. Can you all hear me now clearly? Can you all hear me? All right. So what did I tell now? I'll repeat again. Imagine there's a ring here. If you want to label the ring also. Here the ring, right? Here the ring. And then you have 2 Newton balance. So this is the Newton balance. And you pull, you can find the reading of the Newton balance here. So this is the Newton balance. And you attach a rope or thread to the Newton balance and you pull it. You pull the ring. This is a practical activity. So this also Newton balance. This side also, like imagine this is around 90 degrees angle, and you pull from both the ends. But the ring will not move towards P or Q. The ring is moving in a direction in between P and Q. Between P and Q. That direction of the movement of the ring is considered as the direction of the resultant force. That is the resultant force. Therefore, the ring is moving towards the resultant force. So if you want to write here, the ring, complete the blank here, student. Here I have given what? Ring towards the resultant, towards the direction of P or Q. So ring is moving or ring does not move? Ring does not move. That's what you write. Ring does not move towards the direction of P or Q. Instead, it moves what? Between P and Q. You can write here, the ring moves in the direction between P and Q. Ring, but it moves in the direction between P and Q. Between P and Q. But you are not supposed to calculate it. The value between okay. You don't need to calculate that at all, right? No need to worry about that. Is that clear? Please note down everything, students. So this is a practical activity. I think it's given in your textbook, right? Please raise hand those also writing. Okay. Shall I raise this? What is this called? Resultant of inclined forces. Or sometimes resultant of two non-parallel forces. So the object moves between the direction of the two forces. That's what you have to remember. Shall I read the screen? Right. Then next one is, students. So this one I have given again the latecomers, what we are discussing the last page of the 9th lesson. The resultant forces, we discussed resultant of two forces, same direction, same line. Resultant of two forces, opposite direction, same line or collinear. The resultant of two forces, same direction but parallel. Parallel, same direction. Right. The fourth one is this. Now here also I have given an example. If you can make a small schedule of this, you can write this side one force, this side. Then it's this way the result. R. Again, mark this way also if you want. If you mark the forces P and Q, R will be the resultant force. Or if you mark here 20 Newton and here 20 Newton, 20 Newton. They will never ask you to calculate what is the value of R. Never, never. Just to mark the direction of the R. That's it. That's enough. But actually, this will be what? Between 40 and 20. Answer will be between 20 and 40. Value between 40 and, but that even they don't ask, right? Because you have to use like sine, cos, tan, and you have to get the actual, because when you turn this force toward this side, it decreases, student. You have to turn both these forces this side, then it decreases. That's why it will not remain as 20. But if it is like this, yes, of course you add it. If it is like this, then you add it. If it is 20, 21, then what is the resultant? The resultant will be 40. Because then they are parallel. When they are parallel, the resultant will be the sum of those two. If they are in the same direction also like this, then also 20, 20, then it's 40. 40. Here also 40. But here is you can't add like that when they are inclined at an angle. Okay. Then activity also we discussed. Did you finish copying now? Okay. Then the last one. Sorry, examples. Right. You can see here his practical applications. But these things are not given in your textbook, student. I'll show the textbook, the last page. Unit 9. Textbook. It's, yeah, this one. So the textbook, this is what they have given. Only this much. That also not then. This is only. Only this one. Right? Only this the resultant of two inclined forces. That's it. Then what? They have given next page top. Only one small paragraph. They are not given any applications or like, but when you get the questions in the exam, they ask questions related to the applications of these two forces. Okay. Right. Is that clear? Shall I read the screen? All right. Then next one. That's all they have given the textbook. So this is one example. In which direction sometimes even the school the students sometimes they use a rubber band and do this. This catapult or slingshot. Catapult. Example, catapult. Please raise hand those who have used this catapult. Anyone use this? Like, the real one, you have used this. How many of you? Only Inara and Sanuka. None of the others. I don't know the term they use in Sinhala called Dunna, right? Dunna or something. No, not Dunna. Anyone know the Sinhala term is for this? This catapult? Is that Dunna and Nitale, the second one, the next picture. The arrow goes in the direction. Catapole. Okay, sorry, right. Sometimes it breaks. Okay, catapole, right. Okay, so in which direction it's moving now? You can see that you can mark the two forces here. Two forces you can mark like this. So this is to get the tension, you can mark the tension of this rubber strip. Rubber band also you can do it with rubber band or rubber strip. Like that. So in which direction is moving? It moves in the direction this way. Because these two forces are inclined. These two forces are inclined. Is that clear? This is one force and this is the other force. They are not parallel. Therefore, this is the direction of motion. Direction of motion. That is the resultant. Remember, students, so it's moving along the direction of the resultant. Direction of motion will be the direction of resultant. If you can note down that direction of the motion is also equal to the direction of the resultant force. So even this one, what happened? Please mark the other diagram also. If I don't know whether it's clear. If you have got to print out, this is one, and this is the other one, and this is the arrowhead. What happens now? What is the resultant? Resultant, this is one force. So you can mark the force. Look at the screen. This is one force and this is the other force. But the resultant will be in between those two. So I put F1 and F2. Then the resultant is this. That is the direction of the motion of the arrow. This is the resultant force. So the arrowhead is moving towards the resultant. The arrowhead is moving along the resultant force. So this is again bow and arrow. No? This is called bow and arrow. Use of the bow and arrow, the same principle. Can you remember this students? So this flyover and all is like this flyover, like this. Flyover. In which direction the weight is acting? This one. So this is one direction, this is the other direction. Then what? The weight of this, when a lot of vehicles are going on this flyover, the lot of weight exerted on the bridge or the flyover. So then the flyover, the resultant is acting in this direction, but it's less than the two ends. So it's get divided. You can understand. It's get divided here. But if you put like this, what happens? Then directly the sum of these two. So greater weight. So weight exerted down here, I put here R and here R1. This R will be less, the curved shape, dome shape one, than the parallel one like this. Okay, but anyway, you can't have a road like this, but you have to make like this. But even that, yeah. Okay. There are many other instances. Example, you hang frame picture on the wall, student. Okay, that also hanging a frame picture on the wall. Like this. Or say you can Yeah. When you hang a frame picture, then you get inclined forces. A frame picture on the wall. Picture. That is, so this is the picture. Then what? So this is one force. And this is the resultant. Result is acting down like that. That also a situation like this. Right? These are called inclined forces. These are called what? Inclined forces. I think in Sinhala we call it Anata Bala or something. Anata, like not parallel. Now the last figure, I'll read this. So these are the practical applications or the instances where we can observe inclined forces in day-to-day life. Then 12th one is students. Look at here, 12th one. Write down the direction of the motion of the object in the following instance. Direction of the motion. Direction of the motion in the following instance. When the forces P and Q are applied, what happened to the direction of motion? In which direction? Tell me the out of this P. Okay, let's see P and Q. P and Q. The direction is what? Out of simple letters you are used for the direction. Yes? These are the three forces, P, Q, R. When P and R applied. Yeah, when P and R applied, in which direction the resultant force? Yes, can you quickly reply on chat, students? If you have understood what I explained before, you should be able to tell. It's first P and R. Roman number 1, what is the answer? Hurry up. In which direction is moving? Simple. B. Can you understand? Towards B. Yeah. Okay. Satini, Inara, Gitmi, Harini, correct. Very good. Yeah. P and Q. P and Q. Then okay. I'll ask that again. P and Q. I'll ask again because the number 1 is P and R. So answer is simple. B. Answer is simple B. Right. Simple B. The next one. When forces P and Q are applied. P and Q, P and Q. P and Q. P and Q. What is the answer? In which direction this moving? Ring or object or whatever attached to P and Q, it's moving towards simple A. Right, simple A. Then if you take when P and actually if you want, you can try this even. Practically you can prove this. I will give that, I'll tell that. So the last one, what is the answer? Q and R. Q and R is these two. What is the direction of the resultant or the direction of the motion? Q and R. These two. In which direction the object is moving? Towards C. So it's understood, right? You understood what's happening now. Now, example, I'll give one example. You can take a table and you can have two rubber bands. Okay, two rubber bands. You can take even three rubber bands. Three rubber bands, and you fix this to three nails like this. Three nails. Right? Three nails. This is one nail. And this is the other nail. And this is the third nail. Now, three rubber bands. If you only can make a small sketch of this diagram also, students. Here are the rubber bands. Right? And here the nails fixed on the table. Here the nail. Now you keep an object here, a plastic ball. You keep a plastic ball here. And you cut this, the third rubber band, this one, left side one. What will happen to this ball? This ball will move towards which direction? Towards any of the remaining nail. It will move in a direction in between the two forces. Because rubber band, there's a tension. There's a tension on the rubber band. So it will move this way. This is the direction of the motion. It's same as the catapult. Right? Is that clear, student? Right. Okay, then so that's what you have to understand. You can practice, you can prove it experimentally active by using a small activity like this. So that is the end of this lesson. Now I have shared up to unit 7 unit wise revision papers. Up to unit 7, not to theory group, paper class WhatsApp group. Paper class WhatsApp group, I have shared up to unit 7 revision papers, and then unit 8 and 9 also I'll share, because parallel to the theory lesson students, we are doing unit wise revision. Other than the term test and model papers and past papers, we are doing parallel to this unit wise revision, because we don't have time to discuss all the questions, the textbook exercise and the revision tube papers in the theory class. So theory class only to teach theory. That is Sunday morning, tomorrow morning 5:30. Okay, then I'll erase this. So I think textbook they have given just only one diagram, but I gave a lot of diagrams with applications to understand the resultant of two inclined forces. Right? Okay, then so this lesson is done now. We have to start the 10th lesson. Right? We have to start 10th lesson. So this is done. Now, those who joined recently, the newcomers, if you have a big issue with, or if you have completely lost any lessons, the previous lessons, some lessons actually grade 10. Now I'm going to start grade 10, 10th lesson now. Now remember, you can't understand this lesson, students, if you have not done properly the third lesson. Chemistry, if you have not done properly the previous lessons, this lesson you'll find difficult. I don't know how many of you joined recently, but if you have those who joined recently, like after this lesson, after the third lesson, there's an opportunity, like you can get the recordings, but by you don't need to make a small payment, and you can contact me through WhatsApp and send a request. So then you can cover up that lesson by watching the previous recording, theory class recording. Not for all the lessons, some selected lessons like chemistry third lesson. Chemistry third lesson and 7th lesson, the recordings are available. But if you have done theory in school or somewhere, like, if you're okay with that theory, no problem. Otherwise, you need to revise that lesson at least by that way. Otherwise, you will find it difficult to understand, especially chemistry also. Chemistry, especially chemistry. Right? Then chemical bonds. Chemical bonds. So my question is this: why do chemical bonds are formed between what? Chemical bonds are formed between what? Between atoms. Between atoms. Between atoms. So then what happened? You get new between atoms. When chemical bonds are formed, you get new compounds. New compounds or molecules. New compounds or molecules you are getting. when chemical bonds are formed between atoms, you get new compounds and new molecules. Why can't the atoms stay alone without forming bonds? So, are they man-made? I'll give one example. Water H2O. What is H2O? So, we made this by you take 2 hydrogen and fix that with 1 oxygen and you make the water molecule add into the glass. Right? And again, you take 2 oxygen atoms, 1 hydrogen atom, join them using a toothpick or something, and can you add to the glass? Right? Can you make chemical bonds like that with a human involvement? No. Remember, students, chemical bonds are naturally formed. We don't need to make bonds. They are already formed. We just get it and use the compound or the molecule. Okay. Those who need the recording of the previous lessons, you have to contact me through WhatsApp. Send me a request with the unit. Then if it is available, I'll let you know. But you have to make us, I have to recover all this. And it's a kind of additional work. To the other recording. So, but not everything, some difficult lessons only I have kept the recording. I have to recover that from the Zoom cloud and save it and again upload to somewhere. So there's a small payment you have to make. Otherwise, kind of anyway, I'll give the details. Those who need the recording of previous lessons, please send a request to WhatsApp. Send me a request, WhatsApp message. Then I'll tell you the procedure. Okay. Now, in the periodic table, you had done no grade 10 third lesson periodic table. Students, periodic table what? Periodic table, you write hydrogen H, oxygen O, but nitrogen N, but they don't exist as it is. They don't exist as it is in the nature. Oxygen become O2, oxygen gas. So, periodic table oxygen is O, but we breathe O2. That means chemical bonds are formed between oxygen atoms to produce O2. So chemical bonds can be formed between similar atoms as well as different atoms. So hydrogen and chlorine. Chemical bond can be formed between hydrogen and chlorine. Then what? HCl is formed. Remember, students, chemical bonds can be formed between the atoms as well as the existing chemical bonds can be broken down to form new bonds. That also I have to tell. So example, I'll give one example. Now H2, this is very interesting area. HH, there's a chemical bond. Cl, there's a chemical bond. So we call it hydrogen gas and chlorine gas, right? Hydrogen gas and chlorine gas. Now, when these two react or when these two combine, you can get what? HCl, 2HCl. So for these two combine, so then that means this hydrogen atom goes with that, this chlorine. And the other hydrogen atom goes with the other chlorine. That's how you get HCl. So in order to form new bond, what? The existing bonds should be broken down. That happens in chemical compounds. So the existing bonds will break down like this. This side also the existing bond will break down, ClCl. And then you get a new bond. So therefore, that way also the new bonds can be formed, chemical bonds. Chemical bonds can be formed between atoms, between ions, and by breaking down the existing bonds, new bonds can be formed like this way also. So example now, if you take salt in the kitchen, it can be formed between atoms as well as between ions. When okay, it's chemical bonds can be formed between, that is one example. So I told HH can become between atoms. Right? Between atoms it can be formed. Between hydrogen atoms. HH. Then it can become H2. Right? Chemical bond is this. So we draw a small dash or line between the atoms to represent the chemical bond. Sometimes this is between atoms. This is what between atoms. And yet sometimes the chemical bonds can be formed between ions. Between what? Ions. When chemical bond is formed between ions, so we call it ionic bond. Example, Na plus Cl minus. Then you get what? NaCl. That is sodium chloride, salt in the kitchen. If you are in your show, now remember students, other than the formal theory tude, I give you a lot of additional explanation between atoms, between ions. Then you better copy down these things separately in your writing book. Because later when you study the lessons again, if you have forgotten anything, it's easy to understand. Small summary. Okay. Is that clear, everyone? Okay. HCl. Between atoms, between ions, and sometimes chemical bonds can be formed between atoms by breaking down the existing bonds. Now remember students, when forming bonds, this is also very important. When forming new bonds, energy is released. That means heat is released. That's also very important to understand. Making bonds, heat is evolved. Heat is evolved. That's why sometimes when forming a precipitate by after mixing two solutions, so it gets warm up. Right? When dissolved in salt in water, slightly the temperature decreases, cools down. When dissolved in sugar in water, it's same thing happen, or glucose. So sometimes heat is absorbed. To break down the bonds, heat is absorbed. Heat is absorbed. Or energy is absorbed. Bond breaking, endothermic, heat is absorbed. Bond formation, exothermic. That is additional thing. Additional things. You don't need that for this lesson. Additional point. So therefore, around us, even in our body, the bond breaking also occurs, bond formation also take place. Bond breaking also take place, bond formation also take place. Right? So that means new bonds could be formed. Now the next one, why do they form bonds? Can't they stay alone? Remember students, when a new substance is formed or when the reaction takes place, it's going from more stable form, from unstable to more stable. Like actually atoms are unstable. Atoms are unstable, but molecules are more stable than atoms. That's why in the periodic table you write H, but it doesn't exist as H in the nature. In the periodic table you write O, but it doesn't exist as O in the nature. It becomes O2, H2O, oxygen combining different things. So you also like that. When you are staying alone, you are unstable, right? But when you are united, like group or as a team, you are more stable. You have more power. That's why you stay in a family. So for us also the same thing. So you are with your parents, you have your brothers, sisters, parents. So you are more stable with them. But if you are staying alone outside, so when you go to school, what parents are waiting until you come back. Sometimes they come with you to drop you. They drop you. Or you're going in a van. When you're going alone, when you're staying alone, you are unstable. Is that clear? So therefore, the atoms also like that, students. Sometimes large number of atoms combine like macromolecule polymers. Even so one day like they were done, everyone will die. So kind of no one will live forever. Immortal. So before they marry, before they die, so they will find a partner for you. If you don't find after your studies, after age 20, 30, sometimes maybe when you finish your studies and when you get a graduated, and then parents become very old, they go, like, because any person is going old. So then they will check, they want to see, they will sometimes if you don't find, if you don't have one, they will find proposals. So they will find. Why? Because there's no, otherwise you will be left alone. So then you're unstable. When you get sick, there's no one to look after you. But as a family, when you have children and when you have like partners or wife or husband, so they are around you. So that make you more stable. But the other option also, they are like, there are some atoms in the periodic table, they don't form bonds. Is like example, noble gases. You had done a great in third lesson, helium, neon, argon. They are already satisfied and they don't easily form chemical bonds. Helium, neon, argon, the group 8 elements. We call them noble gases. So the outermost shell is full. They look like kind of some religious people. They're like monks or fathers in the church or nuns in convent. So they don't get married, right? So they stay alone. You got it. But majority, yes, they don't stay alone. Right. So when it comes to chemistry also, students, so this is there. Sometimes some molecules, they get divorced and they find new one, then they form new compound if it is more stable. You understand? So this nature, this behavior is observed in non-living environment also, right? That's what I'm trying to explain you. Chemistry also we see this. So therefore, when chemical bonds are formed, you get new compounds, new molecules, and they become more stable. If they are unstable, they don't happen, it's not going to form. So usually in a chemical reaction, unstable compounds are not likely to form. Right? So if they are energetically more stable, if they are more stable only, that's going to happen. Otherwise, all the molecules will react as it is everywhere. Okay, so that is the background or the introduction to this lesson, chemical bonds. And the next question, who involved in the formation of bonds? Like atom has lot of things. An atom you learn, again I'm telling this, chemistry students, if you miss one lesson, you will find it difficult to understand the next lesson. Now you need here atomic number, configuration, the subatomic particles. Without that understanding, you can't understand this lesson. That's why I told, if any one of you have not done, maybe like some of you join later after the third lesson with me. So if you have not done that third lesson properly, you have to at least get the recording and watch it. Because this is not just teaching the textbook. I am not teaching the textbook student. Textbook is already there, so no point of writing the same textbook note again in your writing book. Many teachers think teaching the textbook and transferring that note to the students' writing book and train them to memorize this and to repeat that in the exam. In many tuition classes also, they will also do the same thing, which is completely wrong. They train the students to remember. But now, with this technological revolution, you don't need to share your memory for remembering this much of data, right? Because you have instantly at fingertips, you can get any data anywhere in the world, any information you Google search, within few seconds, you get million hits. You just search like, one word, like, so you get a lot of things. So the way with AI, right? AI or virtual reality or augmented reality or artificial intelligence, and with all this, so in the future, the education also will get digitalized, plus it will be like kind of a new world beyond 2030, most probably. Therefore, you should get prepared for that, because our age is gone. Now we have, it's that IT buzz, all is gone, but this technological revolution. So you won't be able to survive without upgrading that knowledge, or without, I mean, with even to find a job. This degree is not enough. Right. Now, my question I asked, there are 3 subatomic particles. What? Protons, electrons, and neutrons. We have learned this under 3rd lesson. Those are the 3 subatomic particles: protons, electrons, and neutrons. Out of those 3, which subatomic particle involves for the formation of chemical bonds? Who can tell me? Reply on chat. Whether all 3 involve, or only protons, or only electron, no, only neutron, no, proton and electron, no, like who directly involved in the formation of chemical bond? Sometimes what happened in, even in the marriage, what happened, the what is called kapu or something, the what it is called, matchmaker or something, like, yeah. Yeah, who involved? Very good. Okay, I got the answer from Dilina, right? Dilina. Satini, very good. Yeah, which subatomic particle? Very good. Who involved? Electrons. You better copy down these things, huh? Don't just listen like, you know, like watching a drama here, movie, because you forget it, right? Therefore, the important points you better copy down in your writing book. Everyone should maintain a separate CR book to copy down special notes. So what you have to write now from now, okay, correct, get me, is electron. So what you should write now in your writing book? Electrons involve in the formation of chemical bonds. Please write it. Electrons involved in the formation of chemical bonds. And earlier also I told different things. What you better copy down the important point. What? Chemical bonds can be formed between atoms or ions. As well as by breaking down the existing bonds, the new bonds could be formed. Right? Then I told atoms are unstable. Therefore, atoms combine through chemical bonds to form molecules and compounds. Okay? Those things are important. And why atoms are unstable? Because the outermost shell is not completed, except noble gases. Except noble gases, all the other atoms, outermost energy level or the shell can accommodate more electrons, but still they haven't got full. So when electrons are available at different energy levels. Okay, the next point is what? Electrons of which energy level involved in the formation of chemical bond? Yes, these are the basic things. Without understanding these things, no point of doing this lesson, students. Now, my next question is what? Electrons of first energy level low, the most closest one to the nucleus, or the last energy level, I mean, that is also called valence shell. Which electrons for the electrons in the last energy level called, students, valence electrons. Last energy level is called valence shell, and the electrons in the valence shell called valence electrons. You better copy down these things, or else you better rewatch this recording and note down anything you missed. That is called learning. Not just to memorize the teacher's note or the textbook note and repeat that in the exam. That is like outdated now. Remember it, memorize it. So at the end, what happened? Who enter university? The one who can memorize maximum. And hardworking people, not the skilled people. Students, they don't like to memorize, but they like to argue, like, you know, kind of evaluate, synthesize, like evaluate, innovation, problem solving, critical thinking. So they only should enter university. Not the people memorizing and repeating that in the exam. Okay, my question, I didn't get any answer, any response. Electrons of which level, or what electrons, or an atom has, if you take sodium, what is the atomic number? Sodium atomic number is 11. Yeah, there are 11 electrons. Will all these electrons participate in the bond formation? Or which electron? That's the question. Yes, correct. Satini, electrons of the last energy level. Please note down that also. Are you all copying down? Now, some students I know, like I am not forcing you to on your video. You can't do this, students, while lying on the bed, right? Early morning, you take the smartphone or your device and you lie while lying on the bed, you are doing this. No, it won't work. You should have the discipline because you have to write, no, like, you should have that discipline. You should have a separate place without any other disturbance or without, you do it properly because you have more freedom, but don't misuse that. So you will fall asleep. How can you copy down these things while lying on the bed? I don't know whether it's simple, but anyway, somehow you have to copy down the important points in your CR book. Or you have to maintain a separate CR book for chemistry short notes. What did I tell now? Electrons of the last energy level within bracket. Electrons of the valence shell. The last energy level is also called valence shell. Electrons of the valence shell participate in the bond formation or involved in the formation of bonds, not the inner shell electrons. You better write that also within bracket, not the inner shell electrons. And write electrons of the valence shell or the last energy level is also known as, they are also known as valence electrons. Electrons of the last energy level are called valence electrons. Or you can write electrons in the valence shell are known as valence electrons. They only participate in the bond formation, not the inner electrons. Inner electrons very difficult to take out. Why? You learn ionization energy also under chapter 3. Because electrons close to the nucleus are strongly attracted. Electrons close to the nucleus are strongly attracted. Very difficult to take it out or remove. Right? Then the next one is, that is also very interesting. How many letters are in the English alphabet? 26. How many English words? How many English words in the world? How many words are there in English words in the world? From these 26 letters, how many English words can be formed? Can you give me an answer? From unlimited. You can't tell this much. You can ask even from an English a professor or lecturer, even what? How many English words? So they don't know. That means 26 letters of the English alphabet, there can be unlimited number of English words. But now, if you think about the elements of the periodic table, how many elements? More than 26, right? Periodic table, there are more than 26 elements. More than 100 elements in the periodic table. More than 100 elements. If 26 letters of the English alphabet can combine in a different way, like to form that much of compounds or like unlimited large number, you can imagine the number of chemical compounds in the world. Remember, students, number of chemical compounds in the world more than number of English words in the world. Obviously, if 26 letters form that much of words, so then more than 100 elements, so many chemical compounds. So they can't, therefore you can't memorize them. Now, English professor or lecturer, so do they memorize all the, I don't think anyone will remember all the words of the Oxford Dictionary. If they can memorize everything like a database, then they don't need to use a dictionary. No, it's not possible. You will go mad if you're trying to memorize the whole entire dictionary. Same principle. You are not supposed to memorize all the chemical formulas of all the chemical compounds, the names. You can't finish it. Understood? So these misconceptions you have to first solve, right? Therefore, within a certain limit, you might, like dictation in English, like that, here some compounds you have to remember. But it doesn't mean you have to remember all the chemical compounds in the world. Yeah, around 118 elements has been discovered. So now, so this is the background of the lesson. Now, out of the elements in the periodic table, so shall I read this? Now you can see here they have given here except helium, neon, argon. Except what? Helium, neon, argon. Others are unstable. Here, helium, neon, argon do not form compounds under normal condition. And they are called what gases? Noble gases. All the other atoms are unstable. Why? That means they form compounds. Noble gases, they don't easily form compound because their outermost shell is full. They have completely filled electronic configuration. They don't need to share any electrons with anyone, and they don't need to gain or lose any electrons. So that is the most, you should know the necessity of the formation of chemical bonds. So the outermost shell is full. They have given here the electronic diagrams. Outermost shell here, what? 8. Here 8. Right? The others also like that. That's called noble gas configuration. Here 8. 8. They cannot accommodate any more electrons. So the sodium is unstable. This is unstable. Why it can keep 8 but has only 1. So either they should release this one and receive 7, one of that, to make it more stable, because when it remove this electron, the remaining one become full, or need to gain 7 more sodium, right? Even chlorine has 7, but you know, you have learned no configuration, but it can keep up to 8. So it need 1 electron. So these two guys are nicely matching here. This one is to make it 8. To make it 8, chlorine need 1 electron. So this electron can be transferred from the outermost electron of sodium can be transferred to chlorine. Then a relationship starts from between these two, sodium and chlorine. When sodium lose electron, it becomes Na plus. When chlorine gain electron, it becomes Cl minus. Then between these two, what you get a relationship due to the exchange of electron. That is called sodium chloride, common salt in the kitchen. Na plus and Cl minus. Right? So after that, they become more stable rather than staying alone. That's what happened here. Sodium has 1 electron. Then the remaining one become full. After losing this electron remaining, and chlorine, the outermost 7. If chlorine make 8, then that is also stable. But what happens then? The size of the atom. Now this one has 3 energy levels, then it will go up to 2 energy levels. Chlorine, no change. Chlorine, like, you know, it will not decrease, but sodium ion is smaller than sodium atom. That means positively charged ions are smaller than, if you want, I'll write like this, Na plus smaller than Na. Na plus smaller than Na. Because Na plus has what? 2,8 configuration. This one has what? 2, 8, 1. So which one has more energy levels? Sodium atom. Chlorine, sorry, Na plus, only 2 energy levels. Why? Because the outermost electron is lost. Is that clear, students? Therefore, the size also, the atomic size also changes. Na plus has, if you want to write down, Na plus smaller than Na due to the loss of electron. Note down, these things are not mentioned in your textbook. Hurry up. Na plus smaller than Na. Opposite of this happening, Cl. When Cl receive electron, it becomes negatively charged. So this Cl minus is what? Larger than Cl, the opposite. Because when electrons are added to an atom, they become larger. When electrons are removed from atoms, they become small. Okay. Therefore, the size also will be little different. And after that, they are attracted to each other. Then that form a bond. So these two guys are attracted to each other, which is called chemical, through a chemical bond. That attraction is called a chemical bond that forms sodium chloride, NaCl. So these two are attracted to each other, and that is called ionic bond. Then the chemical bond is formed. So actually, the electronic configuration changes. Changes occur in the electronic configuration. And the size of the magnetics will change. So oppositely charged ions like Na plus and Cl minus. So oppositely charged ion means one is positive, the other one is negative. They are attracted to each other. That attraction is called chemical bond. That attraction is called chemical bond. Between the opposite, that is called ionic bond actually. That bond is called ionic bond because it is formed between ions. Ionic bonds are formed between ions. Between what ions? Positive ions and negative ions. Positive ions mostly formed by metals. Negative ions mostly formed by non-metals. Mostly, not always, mostly. Therefore, basically these ionic bonds are formed between metals and non-metal. That's why we are going to discuss this lesson. One type of bond is ionic bonds. But if they are non-metals, what? Between non-metals like chlorine, HH, OO, oxygen, NN, N2. So then they don't like to lose electron completely because they also need electron, lacking. So then what happens? The electrons get shared among them. Then we call it covalent bonds. That's what we are going to discuss in detail under this lesson. Two types of chemical bonds, covalent bond and ionic bond. You can copy down anything you want here, student. No need to copy down the things already in the textbook. Now, sodium lose electron, chlorine gain electron, and they are attracted to each other when they become oppositely charged. And I told sodium ion, Na plus smaller than Na, and Cl minus larger than Cl. Those things also very important. So therefore, who involved in the formation of, who involved in combining these two guys, Na plus and Cl minus? Who involved? Who is a matchmaker? Electron. Electron. Electrons involved in the formation of chemical bonds. That's why you learn electronic configuration under third lesson. You didn't learn proton configuration, right? You didn't learn neutron configuration. Now you can understand the purpose or the benefit or the requirement of the electronic configuration to understand this. If you don't know the electronic configuration of the first 20 elements, that is the end of your chemistry. To write the electronic configuration, you should know the atomic number. Atomic number is the order, like you have to remember the first 20 elements in that. Memorizing part is there to a certain extent in any subject, but the rest is, you can decide logically. You can remember logically. Understood. Shall I edit the screen? Anyone still copy down? If you have doubt, you can ask. Now let's move back to the theory tube. So all what I explained, I have given in the first page of your theory tube. Theory tube first page. Right. I'll erase this. Let's complete that now. The first page of theory tube. Actually, chemistry is everywhere. Right? What is the meaning of chemistry is everywhere? Without chemistry, you will not have even clothes to wear. You have to hide. You will be naked without chemistry. No clothes. You have to hide behind a tree without chemistry. Everything that you use now, you have pencil, papers, they are all chemical industry students. You have rubber eraser, pencil, ruler, plastic, papers, all the stationaries come from chemical industries. If you have metals, all the devices that you use, metals, no, you can't have plastic, laptops, computers, mobile phones from plastic, clay, wood, rubber. There must be conductors, metals. So metal extraction, chemical industry. If you are under a fan or in an air-conditioned room, so those materials, material chemistry, advanced material, that's also chemistry. So then the technique they use to combine these materials and to get a useful product, they use the knowledge of physics. So therefore, if someone is good in chemistry and physics, many opportunities for higher studies, even career opportunities, right? Yes, Sanuga, it's a dash. We draw a small dash between Na plus and Cl minus to represent chemical bond. But it's not equal mark. If there's a double bond, we draw two lines. For example, between oxygen atom there's a double bond. That's why we draw two lines, two bonds are there. When there's a double bond, it is more strong, right? Actually, students, when you come to nitrogen, I'll come why it is double bond and why is triple bonds under chemical bond, and I'll explain that. But just since you asked that question, if you draw three lines, that means triple bond. That means triple bond. Triple bond. Right? Triple bond. Between this. Triple bond. Triple bond. If you take HH, it's a single bond. Not an equal sign. Okay, Sanuka. It's not an equal sign. This is single bond. Not an equal sign. It looks like equal sign, but single bond, the double bond, triple bond. Which is more stronger? Which one is more difficult to? Yeah, I'll give you the reason why triple bond. Because they have 3 electrons, valence, 3 unpaired electrons in the valence shell. That's why 3 bonds. Oxygen has 2 unpaired electrons in the valence shell. Unpaired electron means they are still alone. Other guys are already paired. Electrons also get paired and become stable. Hydrogen has just 1 electron. Oxygen has 2 such electrons, unpaired electrons. Understand? I will, with electronic configuration, you will learn this better later. Now I'll give, if you want, I will tell that also. Now nitrogen, now what is the electronic configuration of nitrogen? Actually, without writing any notes, you can learn this entire lesson if you want, right? Now 2,5, nitrogen atomic number 7, look at the screen, 2,5, 2,5. How many electrons in the outermost shell? 5 electrons. Now how to distribute these 5 electrons? Usually these 5 electrons, first you have to put one at a time like this around the nitrogen atom. 4 electrons, up to 4 electrons you have to put singly. You can't put like this, like this, 2 electrons, 2 and then 1 like that. Not like that. That is wrong. You can't put 2 couples and 1 single. That is wrong. The correct technique is what? Up to 4 electrons you have to put singly, one at a time, without making any couples, so without making any pairs. If there are more than 4 electrons, so only you can make pairs, or you can make lone pairs, or non-bonding pairs. Example, since there are 5 electrons, after placing 4 electrons, the 5th electron get paired with this. This is called non-bonding pair. That they don't form chemical bonds. Non-bonding pair, or we call it lone pair. Non-bonding pair. Or sometimes we call this lone pair. Paired electrons, shared paired electrons, lone pair. Now this is shared electrons. So this is unpaired electrons. So actually, one paired electrons are there, unpaired electrons also there. Okay, if you can note down that also. In the valence shell, there can be paired electrons as well as unpaired electrons. Paired electrons also there, unpaired electrons also there. So which electrons then participate in the bond formation? Earlier I told electrons in the valence shell participate in the bond formation and not the inner electrons. Never, ever. Inner electrons. Inner shell electrons do not participate bond formation, only the outermost electron. Outermost shell also, which electrons can easily participate in the bond formation? Unpaired electron. Now you can see I have distributed all 5 electrons of the nitrogen. Near the atom, you have to follow the same procedure, same technique, up to 4 single, and then you can make pairs if there are more than 4 electrons. So these paired electrons not involved in the bond formation. These 3 unpaired electrons of one nitrogen atom get paired with another 3 unpaired electrons of the similar nitrogen atom. They come to the middle like this. That's the purpose, that's the reason of writing 3 lines between nitrogen atom. Did you get it now? Who asked that question? Since you asked that question, I replied. Otherwise, I was planning to explain this later. But you asked before that question. So this lone pair, both the nitrogen atoms, that lone pair, non-bonding pair remains all as it is. Is that clear now? You better copy down these 3 steps. Then you learn this without even writing any notes. This is how it happens. This is how it happens. This is how we represent it. Can you round down this leftmost side? Everyone, can you all see the screen leftmost side? Yes, Gitmi. If you want, you can put the pair anywhere you want. Left side or right side or bottom up. You can put the lone paired electrons. You can put. There's no rule like you have to put always at the top. You can put it, no problem. Then how many electrons come to the middle? From one nitrogen atom, 3 unpaired electrons. The other nitrogen atom also has 3 unpaired electrons. 3 unpaired electrons. Altogether 6 unpaired electrons. 3 from each. Then these 6 unpaired electrons come to the middle and form couples. So form pairs. So those pairs are called what pairs? Bonding pairs. Those pairs are called what pairs? Bonding pairs. Now from where did we start? From the electronic configuration. From where did we start? From the configuration. From the configuration, we convert that into a dot symbol of nitrogen atom. I taught you how to make this dot symbol, right? For nitrogen atom, but after the configuration, you look at the outermost shell. If there are 5 electrons, so up to 4 you put singly, and then the remaining one you have to make. This is not given in your textbook. This technique not given in your textbook. The students directly memorize. That's what happened. Without understanding, they memorize. That's why they find this difficult lesson hard. But without, I am telling the correct technique, which is valid even for your A-level chemistry. If you follow this technique, you will never do any mistake in all other chemistry questions. Can you please quickly copy down this before I erase this? So can you see here this when the outermost shell is filled, then they don't form chemical bonds anymore. They have given a paragraph in the textbook here. Helium, neon, argon, what? Atoms of neon and argon, what? They have 8 electrons. So they have what? A stable electronic configuration. Because of that, their reactivity is very low. If they ask in the exam a question, why helium, neon, argon, noble gas, their reactivity is low, you are right, but they have stable configuration. They have completely filled outermost shell. But the other atoms, no, they don't have. They need, they can accommodate more electron. Then how they achieve noble gas configuration? By receiving electrons. Receiving electron or by removing electrons or sometimes by sharing electrons. So what is this technique called? Gaining by someone or losing or by sharing electrons. By sharing electrons. All right. But how they become stable? By losing electrons. So by now here, what did they do? There are 3 unpaired unmarried guys. The nitrogen has 3 unpaired electrons. Outermost shell 5 electrons out of them. So any other atom you can do this. Any other atom you can do this from the first step. And then you can check they can form how many bonds they can form. All the electrons that between the atoms called bonding pair. What is this called? Bonding pairs. How many bonding pairs? 3 bonding pairs. 3 bonding pairs. How many non-bonding pairs? Each nitrogen atom has a non-bonding pair. This is the non-bonding pair. Non-bonding pair. Sometimes these non-bonding pairs are also called lone pairs. What are the 2 types of pair? Now, after forming bonds, there can't be any unpaired electrons or unmarried guys should not be there around the atom. Once they form a molecule or a compound, all the electrons are in the form of pairs. But before they combine, before they form the bonds or the molecule, there are unpaired electrons, single electrons occupied in that. Understood now? You better copy down these things using your own words. Because mostly you memorize someone else not. Why don't you make your own note? Why don't you become the writer of your book? So you are writing, but you write someone else's idea. But you can put that into your own words, own sentence, which gives the same meaning. I don't know whether you understand what I'm saying. Most of the time you memorize teacher's note, the tuition master's note, so the textbook note. That means someone else's note. But you don't understand that method, or you don't understand that writing, that explanation. Because that is their understanding. According to their understanding, they take it. But you might understand this in a different way, but the same thing. Different in the sense like the same thing, you also get the same output, same outcome. Example, now you can see sometimes some people, they like novel, English, Indian books, because that English is easy to understand than American books, something like that. So, but when you understand something and when you put that into your own words without missing those important technical words or the scientific term, you can look at that again at any time and remember it, or you can recall it, you can understand it. Some students, so I have seen, they don't know what they have written. They have pages and pages the notes before the oral or A-level exam. But some of the notes, they can't read. They don't know what they have written. They copy on all what the teacher is saying. Sometimes they don't know what does that mean. Like even they don't know the meaning of that sentence. So that is the problem. That is one barrier for your studies. Because when the teacher explains, they don't listen. They have some other business with their friend or having a chat or something. Then what happens? When the teacher start giving the note, only they stop everything and copy down, but they don't know what the teacher has said. So they have nice notes, decorated diagrams and color underlined, colorful, highlighted one pages, like very nice, but no marks in the exam. They have nice notes. So remember, that is you have to correct. If you are not performing well, that means the current method you are using is wrong. You have to change your method. Now, Sanuka, here 3 bonding pairs and 2 non-bonding pairs if you take both the nitrogen, but if you take 1 nitrogen, 1 non-bonding pair. But these bonding pairs, it's like they belong to both the atoms. Bonding pairs, you can't tell now this is only to the left side nitrogen atom or right side. The bonding pairs belonging to both the atoms. Non-bonding pairs belonging to the individual atom or the one atom. That's why we write them in the middle. That is called sharing electrons. What is this called? This method of forming bonds called by sharing electrons. By sharing the electrons, not only one atom. Sharing means there must be 2 parties to share it, 2 atoms. Understood? So those bonding pairs only we draw, we represent using a small dash or line, the bonding pairs. 1 bond means 2 electrons, right? 1 pair, 1 bonding pair equal to 1 bond. That also you have to understand. 1 bonding pair equal 1 bond. 1 bonding pair equal 1 bond. 2 bonding pairs, double bond. Single bond. 1 bonding pair, if there's only 1 bonding pair, that is a single bond. Is that clear? And 2 bonding pairs means what? 2 bonding pairs means double bond. You have to draw 2 lines like oxygen. Now let's see why oxygen form double bond. Why oxygen double bond can't oxygen form to a single bond? You can explain that. Shall I read the screen? We can nicely. You can even explain me that using this knowledge. You can explain me even. You can take 1 oxygen atom, write the configuration, and put the electrons around that oxygen atom. Then you will understand. Okay, shall I read this? Let's see oxygen now. Oxygen. What is the oxygen configuration? If you don't know the configuration instrument, that is the end of your chemistry. Okay. If you don't know the atomic, that is chapter 3. Chapter 3. Chapter 3. Oxygen. How many? What is the atomic number? Actually, I have done more than 50% of the lesson without looking at the theory at all. Right? I have taught you. You don't know that if I give notes like long paragraph for all these one by one, you will find, oh, this is one. There's a lot to study. This is very hard, but this is nothing there, right? If you get the concept. Now I am putting the concept to your head, then after that I'll go to the theory too, right? Then it's easy. Then you can understand any note, my note or a textbook note or the teacher's note or a textbook short note or whatever. You can read and understand if you get this concept to your head. Oxygen atomic number 8, right? 2,6. Outermost shell, how many electrons? These are called valence electrons. Electrons in the outermost shell called valence electrons. Valence electrons, right? So who involved in these valence electrons only forms bonds. They form bonds. Sorry, chemical bonds, right? Okay. Now let's draw that diagram dotting up to 4. What is the technique now? Outermost electrons or the valence electrons, how to allocate around the atom? Only one at a time, up to how many electrons? Up to 4 electrons. With the fifth electron, we make pairs. With the fifth electron, beginning of the fifth electron, how many electrons left out of 6? We have already distributed 4 electrons singly. 2 more left. That means you can make how many pairs? Only 2 pairs. Only 2 pairs. Like this. So this is called unpaired electron. How many unpaired electron? Oxygen atom has how many unpaired electrons? 2 unpaired electrons. How many pairs? 2 pairs. 2 unpaired electrons and 2 pairs. 2 pairs means 4. 4 plus 2, 6. Now you can understand how many bonds between oxygen atom now. To form one bond, 2 electrons. So that means what? Both the oxygen atom having these 2 unpaired electrons. That means 4 electrons will get shared. 1 electron of this oxygen atom with 1 electron of the other oxygen atom. Unpaired electrons get paired like this. If I put this side also oxygen atom like this, then what happens? These, I will highlight like this. Look at the screen, everyone. Stop writing. This is what? This unpaired electron get paired with this. And then you come one bond. And the other unpaired electron I put like this. This is the other unpaired electron. This one, and it will come here. Now what happened? How many bonds now? Double bond. If there are 2 unpaired electron, double bond. If there are 3 unpaired electron, triple bond. Now did you get the answer for your question? Someone asked me for, sir, why triple bond nitrogen? Why double bond oxygen? Why hydrogen only single bond? Can't we make more bonds than that? Now lone pairs you have to represent as it is. This is called, student, Lewis dot diagram. This is called what? Lewis dot diagram. The scientist who introduced this method called G.N. Lewis. This is called Lewis structure. This is called what? Lewis structure. Is that clear? Lewis dot diagram and Lewis structure. There are 2 pairs. No, yeah, there are 2 pairs here. You can put the pairs anywhere you want around that, no problem. There's no rule like you have to put top and bottom like that. Is that clear? Yes, Sanuka, it has 2 non-bonding pairs. Understood? Did you get why oxygen from double bond? Oxygen gas that you inhale, O2 gas that you inhale, this is the structure. So when there's now if you only write triple bond is more stronger than double bond and double bond is stronger than single bond, can write that also. Now if you are planning to do, if you're planning to do your A-level science subjects, right? Science subjects. This knowledge is very, very important, very useful. Because I am giving a little bit extra always. That is targeting that A-level crowd. That means you have better understanding than the others about that subject from your O level. Then you will perform better than the other A level students when you're doing A level. So that is for them. But the basic things for the students also are doing all that, because some of you are planning to do A level commerce, arts, but in the future you will be jobless if you without technology. So without you need, it's technological revolution in the future. All this you get smart devices, digitalized world, digital world, digital currency, and everything. The education get digitalized, digital technology, digital technology. So that is technology. So sometimes they might surpass our human capital will not be necessary in the future when the technological stuff come to the market. You become jobless. That means what? There can be robots in the supermarket. Cashiers, customer care executives, receptionists, all they get, because you don't need to pay salary net to them. You can, just do energy like the current, electricity, and then they will do the job from until morning. You don't need to give food. You don't need to give any other way. They don't strike. No, they don't ask salary hike. You can keep the place open for customers 24 hours. They don't sleep. Therefore, the private sector, what the owners of the business, they prefer profit. They target profit. So with the human labor, what very difficult to handle. Sometimes they will steal the stuff of the shop, the goods. They will do mistakes. They will fall asleep. The person, while doing some sensitive jobs, it can cause a lot of issues. So actually, I don't know whether you experienced that during COVID-19. Sometimes what? The trolley is coming without the nurse and the doctor near the patient. And there's a camera and the mic. Through that, they communicate with the doctor. In the future, without visiting the hospital, you can get treatment other than the surgeries. This medication. You can order the medicine also, and that will also be delivered to your house. That is artificial intelligence vehicles. Without drivers sometimes. You can see that kind of world, students, you will, but I think for us, so we will be able to survive, but your time and your children's time, it will be a new world, not this world. Right? Okay. Then next one. So what are some triple bond? Give me other than nitrogen, this carbon also can form triple bond. Carbon also can form triple bond between its atoms. In your syllabus, out of the first 20 elements of the periodic table, carbon and nitrogen form such triple bonds. And when there's a triple bond, it's difficult to separate the atoms, because to break triple bond, more energy required than double bond. To break double bond, more energy required than single bond. Okay. Is that clear, students? Okay, shall I read the screen? Anyone still coming down? You better note down these things in your right book. The tutor also there. This diagram is called the last one, Lewis structure. I mean, these two, this is the last one, Lewis structure. That means bonds we represent using only the bonds we represent using dash, right? And if you represent bonds also using the pair of dots, that is Lewis structure, Lewis dot diagram. This is called Lewis dot diagram. The last one is called Lewis structure. This can be used for the other chemical compounds also. This is called the Lewis, the name of the scientist, Lewis dot diagram. That is only dots. Dots means what? Bonding pairs and non-bonding pairs. Bonding pairs between the atoms. Bonding pairs always between the atoms. Bonds between the atoms. Between two atoms, bonding pairs. That means bonding electrons will be between the two atoms. That is shared electrons. Shared electrons between atoms. The last one is the Lewis structure. What is the difference between the Lewis structure and Lewis dot diagram? Actually, without giving any paragraph, I think I taught more than 50% of the lesson now. I have taught you more than 50% of the lesson without giving notes. Lewis is the scientist who introduced this concept. Lewis dot diagram. Look at the screen. I have put 2 cages. The last 2 cages. Lewis structure, the last one, and the one before that, Lewis dot diagram. If you want, you can write, you can label this one as bonding pair, non-bonding. So these are called bonding pairs. These are called bonding pairs. And the other one is called non-bonding pair. Here the bonding pairs. Here the bonding pairs. And the other one is the non-bonding pair. This is the non-bonding pair. Non-bonding pair is also known as, students, lone pair. Lone pair. Each oxygen has a non-bonding pair. That is also, you can write within by lone pair. Same any other molecule, the same thing. This won't change. Number of lone pairs will change. Number of non-bonding pairs will change. This one. I had put one non-bonding pair. Sorry about that. This one, there's one non-bonding pair. Lewis dot diagram. I had to put one more non-bonding pair because look at the initial atoms. Got it? Okay, hydrogen is very easy. Like that is just one electron, and hydrogen has no non-bonding pairs, only bonding pairs. Hydrogen, H2. Done. Shall I erase this, students? Did you finish copying down oxygen and nitrogen both? How nitrogen become triple bond, how oxygen become double bond, now I explained, right? To everyone. Nitrogen is N2. Oxygen is O2. So this is how we represent it. This is how we represent it. Have you done both this in your writing book? The step by step. Then you will not do any mistakes in the exam. If you want, you can say, let's say in the middle one, hydrogen. Hydrogen. What is the configuration? This is H2 gas. Hydrogen, just one electron. It has just one electron, right? So if hydrogen can keep maximum how many electrons? First energy level of any atom can keep maximum 2 electrons. First energy level of any atom can keep maximum 2 electrons. First energy level of any atom, the first shell can accommodate maximum up to 2 electrons, but it has only one. To make it full, one more lacking each atom. Therefore, what they do, they have no pairs, only unpaired electron. Just one unpaired electron each hydrogen atom. Then they come and get paired in the middle. Now what happened? They have 2 electrons because bonding pair belonging to both the atoms. That's why they come and stay in the middle. That is how you draw hydrogen. So hydrogen, this is the Lewis dot diagram for hydrogen. This is the Lewis dot diagram for hydrogen. This is the Lewis structure for hydrogen, the last one. Is that clear, everyone? Understood? All right. So now you learn 3 molecules. Actually, are these metals or non-metals? Are these called metals or non-metals? So hydrogen, oxygen, nitrogen, are they metals or non-metals? Are they solid or liquid or gas? Nitrogen is the most abundant gas in the atmosphere, students, 78% by volume. Oxygen is the second most abundant gas in the atmosphere, 21% by volume. So they are diatomic. These are what all three are what gases? Diatomic gases. 2 atoms combine. What are these called? Diatomic gas. That also you can write. Diatomic. Diatomic gas. Or diatomic molecule. As well as is a gas. All three diatomic. Diatomic. 2 atoms. And they are gases, physical state gas. And but if there's a metal, it will be a solid. So these bonds are known as what bonds? Carbon form 4 bonds, but with 4 different atoms, not between them 4 bonds. See, it will never become C2. C2 cannot happen. I will tell you the reason later. Carbon can form bonds with the other atoms. Now this is homoatomic. OO2, HHH2, NNN2. That is homoatomic, but heteroatomic also there. I'll come to that next week. Otherwise, it's too much for you within one day. Bonds can be formed between homo, similar atoms, as well as bonds can be formed between heteroatoms, different atoms like CH4, methane, CH4, HCl, hydrogen chloride. So that's also possible. Gradually, we'll next week I'll give the heteroatomic ones. Let's see homoatomic one. And these bonds are called, students. So how many bonds here? Oxygen, 2 bonds. These 2 bonds are called covalent bonds, right? Such bonds are called what bonds? Covalent bonds. How many covalent bonds? 2 covalent bonds. That also you can mention. Covalent bonds. And this one has what? Hydrogen also has what? 1 covalent bond. Why are these called covalent? Because these bonds are formed by the sharing of the unpaired electrons of each atom. Unpaired electrons of each atom come to the middle and get paired with the other atom electrons. Understood now? Okay? Is that clear? Did you all finish copying down? Please raise hand those who are still writing. If you have doubt, you can ask before I erase this. If you need any clarification related to this diagram, any question related to this, you can ask now before I erase this. And that also you better copy down under the same note. Right. Then there's a question here. So what are some doubts? Bond atom. What are some doubt? Double bond atom. I told you double bond atom. What O2 in your syllabus? Double bond atoms O2. And there's something called alkene also. Carbon also can form double bonds and triple bonds. Carbon can form single bond, double bond, triple bonds. You can write that carbon can form all three: single bonds, double bonds, triple bonds. That's why organic chemistry, there are a lot of compounds contained in carbon. Sanuka, the covalent bond is formed due to the sharing of electrons of the atoms. If electrons get paired between atoms, so that such bonds are called covalent bonds, right? Covalent bonds are formed by sharing electrons between atoms. By sharing electrons between atoms. Covalent bonds are formed by sharing electrons between atoms. Is that clear? Shall I erase the screen? Any more questions? Sanuka, okay, how covalent bonds are formed? By sharing electrons between atoms. Which electrons get shared? Unpaired electrons. Unpaired electrons also which energy level? Last energy level. If you want to write within by blood. Inner shell electrons are not involved in the bond formation. Only the outermost shell electrons or valence shell electrons involved in the bond formation. Carbon monoxide is kind of carbon monoxide. It has a different structure. Yes, to a certain extent, it's actually not diatomic. It has a coordinate covalent bond that is beyond your oral chemistry. Actually, there are 3 bonds. That is a heteroatomic carbon monoxide. It's a poisonous toxic gas. Yeah, get me carbon, each electron, there are 4 places, 4 bonds around that. CH4, CH, CH, CH around carbon atom, there are 4 hydrogen, 4 separate hydrogen, 4 separate single bonds. Carbon 4 bonds cannot be formed even though carbon has 4 unpaired electrons. Okay, any more questions? Yeah. Right. Okay, then students. So we'll continue the rest next week. I'll directly now, just to complete the note, the filling blanks in your theory tube now, up to here. So I put this whole concept to your head without giving any long paragraph, but I hope you understood this. Definitely you have understood this without writing notes. Now the note is in your head, not in the book. Mostly what happened, the opposite. You feel the note and you try to memorize that. So actually you have to do the opposite. First you understand the whole concept, the entire lesson, you can store in your head, and after that you can write the note. But mostly what happened, the opposite of this. That's difficult. Right. Okay, then about 2 or 3 minutes left. So we can't start a new section. Time is not enough. So then it's almost 8 o'clock. We'll stop for today, students. If you want, you can watch this recording, send me a request. You can within 3 or 4 days, you can watch any number of times the recording. If you want to rewatch this and complete anything else you miss, please send me a request to WhatsApp. And please upgrade your name code. Those who have not got the name code, please remind me with your payment receipt, because I am taking attendance. Those who are not joining the class regularly, I will, without informing, I will remove them from the group, because I don't need students, those who are not doing this properly. Right. All right. Okay, then have a good day and God bless you. We'll continue the rest next week. If you are not still got the name code, so just remind me to the visit. Yeah, I'll send the name code.